Hi everyone, this video is about YOLOExplorer and where it's at right now. I've made a few updates mostly related to GUI interface, the dashboard, and I just wanted to cover a little bit of that in this video. This is still needs to be installed via GitHub link, which again is not that complex, but yeah, I think once we have a few things ironed out, this can be just hosted on like built on PyPy index. So but yeah, that's I think a week far. So I'm going to focus on dashboard now, and of course Python and notebook interface are still supported. Everything is built on top of that, but it's my assumption that when you're doing something with a large data set, it would make sense to use a dashboard. That is what the recommended workflow would be, because you wouldn't want to view your images in Python plots or notebooks. So let me just get started. And you cannot see me in this video because I also aim to put this video as a tutorial on GitHub itself, but let's see how it goes. I've never done that before. Okay, so the idea is right now it supports not Cocoa. Right now it supports YOLO dataset format, with more dataset formats coming in the near future. So you start by creating an Explorer object and pass in a desired dataset. I pass in VOC, and you don't really need all of this. This is just for my demo purposes, but the simplest structure would be you create a Explorer object and you can do all your Python stuff here. But once you decide that, okay, I need to view this in a dashboard, you can just launch a dashboard like this. But in this example, I'll also pass some secondary datasets that can be used as your data lake or your secondary sources to enrich the primary source. So it is pretty simple. You just create as many Explorer objects as you want, and you can pass them as the secondary dataset as Explorer objects, right? So this is probably simplest. There are some other things that you can pass, which I won't discuss. Those are like plugins and add-ons. So what do? You simply just launch this, and so build embeddings will actually build the tables that we will utilize, LansDB tables. And the good thing about this is that it essentially reuses all of those. So you just need to compute them once. So you see, it says that it is just in the logs, you'll see it tries to it says that embedding space already exists, so it will attempt to reuse it. You can force rebuild it if you want to change the model. So you'll get this. I'll show what all these things are. Let's focus first on the dataset, because that is the crux of the dashboard. So here you see your three datasets, because we passed three, one primary and two secondary. So you will see n number of tabs, and here you see total number of samples, and 250 of them are displayed by default. You can change that number. I can change it to 500. It's pretty quick, and it just loads all of them. I'll just switch back to 250. It really depends on how much memory you have free. I usually have like a lot of tabs and a lot of browser windows open, so I'll just be careful. Start index is where you want to start it. Select all will simply allow you to select them at once, and this will be useful in some operations. Labels will essentially plot all the labels. I prefer to keep it this way, because this way I can actually take a look at the images itself rather than looking at a lot of boxes if there are many, but I'll just leave it for now. Okay, so let's just consider a scenario where you have an image and you have a data set, and you've seen that it performs really bad on certain edge cases. For example, let's just say it performs really bad when there is a horse and a person. It confuses them often, right? So how can you pin down on, like, double down on those kinds of data set, right? How can you pinpoint those? So you can run SQL queries powered by LansDB SQL engine. So I'll just show you a quick example of this SQL query. So I'm gonna write a SQL query that says show me the images that have at least one person and at least one horse, right? So labels are like a person or horse. So I will run this query, and it should show me exactly that, right? Now let's say I want to enrich these kind of bad examples using my other two data sources, which is this and this, right? So I'll come down, and to make this, or maybe let's do something else, right? I can probably do something simpler, which is let's do aeroplane, just to show it to you. Okay, all right, now right, so let's just assume that the model does really well on standard type of aeroplanes, but it does really bad on like vintage ones, right? So for example, this, maybe this. So let's select a few that the model performs really bad on. And now to enrich them, what we'll do is we'll just add them to stage. Now once you do add them to stage, what happens is they are at the top of the staging area, and this staging area is accessible across data sets, right? So it's an interface that allows you to sort of search across data sets. So I can come here and say, okay, I can search similar images to this, right? For example, I can say, show me similar images to this in this data set. This is similarity search, right? So this will show me similar images to this in this particular data set. But it's useless because we are searching in the same data set, right? So let's do the same thing in Coco 128. We come here and let's just say we want to see at least 50 images, and which is similar to these images. Okay, so it shows me a few aeroplanes, right? So I can select multiple or at least one image, right? If I select multiple, what happens is the embeddings will just be simply averaged out. So let me just select all of them in similarity search. Again, this is powered by LansDB vector search. So you will see some aeroplanes are at the top. Excuse me. So what I'll do is to enrich that. When you are in secondary data sets, what happens is you will see an option to either add to stage, which is the images will go here, or you can add to the primary data set, which in this case is VOC. So what I'll do is, let me just show you. VOC had, if I re-render the images, okay, never mind. Let me just, yeah, I selected these three, right? So I'll just add these to VOC. Okay, now VOC increases the sample size by 3. I'll show you how. So it's like 16,551. Now it's 16,554. So I'll just to showcase that these images have been added, I will increase the starting index to the very last. So you see these 3 images have been added from the VOC 28 dataset. I can also do the same from here. I can add like a couple images to VOC, and that should probably I'll render images, and yeah, so I'll do the starting again at this index, and you'll see those 2 images are here. Okay, now let me just go back to this. Okay, let me just clear the staging area because we don't need it anymore, and we are back at starting index 0, and we see this sample right now. What do we do? How do we persist this? So there are 2 options. You can either reset this or you can persist it. So when you reset it, it will go back to the original. It will remove all the things that were added or things that were removed, right? Which brings me to the next part, which is you can also remove bad examples if you want, right? There may be some mislabels and stuff like that. So let's assume that these top 250 images are all mislabels. So I'll select all of them, and I'll simply click this bin icon. I can remove all of them. So now you see the sample size goes down by 250. Now let's say I want to persist it as my new data set. So I'll just simply click on persist. It will create a new data set within a couple seconds, and it will give me my new command that I can use to train this, right? So it created my YAML file, and if I just copy and paste this command here on my terminal, it should just train. It has created this dataset and it will start training on this. So what we'll do is we'll just confirm the number of images. It should be 16304 or 306, sorry. Yeah, here you see it's, I'll just exit this, and it's 16306 images, which is the new dataset. Okay, I'll just rerun this example again to showcase some other things. So I've just walked through like the very simple workflow. There might be like a lot of iteration in the staging areas, and you can add and remove images from there as well and things like that. But the basic idea is really this, that it simply allows you to run searches within the dataset or across the datasets, and combine stuff, right? And then the idea is that the faster you iterate on your dataset, the better you can iterate on improving the model performance, right? And it brings you the tools that you're already familiar with. You, as a data person, you might be knowing data frames, you might be knowing SQL, And if you're not, it's pretty simple language, right? It's not that difficult. And there are a lot of exciting things coming in the future to this. I will probably add a natural language search, which will be powered by some sort of GPT or whatever API, so that you can simply search using your natural language. But that's in the future. What the next thing that I wanted to showcase was this. So the table will give you the tabular view of your data. This is how it's stored in LandsDB, because it's built on top of tabular structure, right? So here you can see the schema itself, your IDs, which are essentially the indexes, and then your path of the image. Images are currently stored, it assumes that the images are stored locally, and soon, like, we can extend this to add cloud storage and stuff like that. The classes, the labels and stuff, and you can see your boxes, you can see your vector that is used for the similarity search, and you can just sort stuff by class or labels or whatnot. And here you have the embeddings. The embeddings are reduced in 2-dimensional, and then the reducer algorithm used here is TSNE or PCA, with UMAP coming soon. This doesn't make any sense because it's very preliminary phase of analysis. So yeah, the analysis tab is coming soon, but again, it will look something like this. It will give you more insights into your data sets. So yeah, once again, you have this powerful tool that simply runs these powerful queries or similarity searches across your entire dataset, or across even multiple datasets within seconds. Like, I can show you again this example where I'm searching for this car, and I selected a couple cars and it showed me that, right? Let's say I wanted to search something similar to this particular car, and you can get so the image that is most similar to that particular car is this particular bike, and so you get the idea. It's pretty fast. You can search things across data sets. I stage this, I come here and I search for this, and if there are cars it will show me, but there are none. So, and I can also like combine the staging area as like a free for all sort of place, right? You can add stuff from any data set. So I can add this bear and this giraffe here, not to VOC. I wanted to add it to staging, but yeah. And then I can search here for this particular giraffe. So it's very flexible. It's so it gives me like something that is closest is like horse and stuff. So yeah, that's where it's at right now. The future is that there will be more customizability more customizations in querying. You can sort of pin down much more, and then there will be more analysis stuff, and then support for more type of file systems and data set formats. So that's the quick update from YOLOExplorer project. It's not really like I'm not really devoting a lot of time here, so if there's any feedback, please feel free, and if there's like enough demand for anything, I'll be happy to build. So yeah, that's pretty much it for this video. See you next time if I decide to make another one. Thanks. Bye.